Hello, my name's David Runciman, and this is Past, Present, Future. In today's episode in our series about the history of bad ideas, we welcome back the geneticist and science writer Adam Rutherford. The idea that he's talking about today is taxonomy. The Swedish biologist Carl Linnaeus, roughly 300 years ago, came up with a system of taxonomy that still organises the way we think about and understand the natural world. And Adam Rutherford is going to explain the harm that it did and the harm that it continues to do. Adam, the last one that we recorded about a bad idea was about an idea I think most people probably instinctively understand, particularly once it's explained why it's a bad idea, eugenics. The idea we're talking about today is maybe more of a stretch. It's probably more of a stretch for me. I'm really intrigued to know and to understand why this is a bad idea. So we're talking about taxonomy, which is a general term, but also can have a fairly specific meaning. And I think we're going to focus on a fairly specific sense of it. But it's probably going to take some unpacking to get to what's really rotten at the heart of this idea. And maybe we should start with a person rather than the idea, and that's with Carl Linnaeus, with whom this term is often associated. So this is by no means the only use of the term taxonomy, but Linnaeus was responsible for a taxonomical understanding of the natural world, which persists to this day. So should we start with him? I don't think he was a bad person, so this is a bad idea, but not a bad person, which is part of what we're doing here. Just tell us a bit about who he was before we get on to his big idea. Who was Carl Linnaeus?
Sure. It's right to start with Linnaeus and to talk a little bit about him and the system that we still use today. I'm not sure how committed I am to this as being a bad idea, but I think it's really worthy of discussion. Anyway, Linnaeus is a Swedish botanist in the 17th and 18th century, and amongst other things, his key intellectual legacy is that he attempts to create and impose a system of taxonomy, of classification of all living things, plants, animals. He also includes rocks. So this is a period where geology is of great interest, but that doesn't really catch on. Whereas for the other two categories, it catches on with universal and apparently eternal stickiness. So the key idea is that the system that he effectively sets up is a classification system where we have genus and species. We have Latinate names for all living organisms, which are genus being a category of shared characteristics and species being specific to the individual types within that genus. Now, it's the system we use. We are Homo sapiens, genus Homo sapiens, species. There have been 9 or 10 different Homo species over the last 500,000 years or so. All plants are categorized like this, all living things. It allows the universal and Latinate language to be shared amongst all biologists and, by extension, all humans. It's useful and interesting, and the reason I think that it's potentially a bad idea, or the nub of why I think it's a bad idea, is because it's only interesting and useful until it's not. It comes from an era, a pre-Darwinian era. So Linnaeus is before Darwin and before the notion that the universally accepted and we scientifically correct view that all organisms are 4-dimensional in that they go through time as well as space. But it comes from a time when classification was associated with a sort of pure creationism, not a biblical creationism necessarily, but a Platonic description of organisms, that this is the archetype of an organism, and other versions are simply derived from or different versions of this standard version of a duck. It also is associated with what was a long-standing idea in biological sciences since classical times. Aristotle thought about this, which is scala natura, that there is a ladder of sophistication and complexity, which starts with the most basic things. This is pre-microbiology, so the most basic things are small insects. And it goes all the way up in a ladder, in a scale. It goes all the way up through to we are not at the top, because in the pure religious version of this, we are a little bit below angels, who are a little bit below gods. But Linnaeus is very much in that tradition. My animosity towards the idea and towards Linnaeus's intellectual legacy is not that. But the fact that it is a reflection of a creationist ideal and not a Darwinian idea is it's the beginning of why I started to become hostile to the concept of classification.
And before we get into the ways in which it can be used and abused, on Linnaeus himself, when I was reading a bit about him before this conversation, he was revered in his lifetime. People talked about him as one of the great Europeans, up there with sort of Shakespeare and so on. In the last episode, you talked about there being a genuine Darwinian revolution. In a sense, there's a sort of before and after Darwin. But as you've just described it, Linnaeus is not that. He's not revered in a sense because he's the person who changed the way everybody saw the natural world. It sounds a bit more like he was revered because he reinforced in some ways and gave a scientific underpinning to something that people kind of believed anyway, which was scale and hierarchy and this way of thinking about variety within a kind of uniformity. And he didn't fundamentally challenge the religious order, which Darwin did. I mean, one of the reasons the Darwinian revolution was a revolution is that a lot of people read his book and they stopped believing in God. I mean, they literally did, some of them. I mean, he really shook the foundations of people's faith. Linnaeus is not one of them, unless I've misunderstood it. He's revered for different reasons.
Yeah, so I don't want to annoy the historians at the Linnaean Society any more than I already have done, which is not inconsiderable. He's a stamp collector. Right? He did something which I think is kind of important in biology. And we went through a similar sort of process in the 90s and into 2001 with the Human Genome Project, which in the purest sense is not a hypothesis-driven scientific endeavor. It's that the only way that we can progress in biology is by having a really, really great data set of genomes. And it was criticized heavily at the time for being, well, why are we spending so much money on these grand projects? And there's plenty of legitimate criticisms of the Human Genome Project, but it is difficult to see how we could have made progress without now having this huge data set to which we can all extract hypothesis-driven questions from. And I think Linnaeus was a bit like that, in that recognizing that as science is beginning to develop, and particularly fueled by the fact that with European empires expanding and sending back plants and animal species and humans, that there was a feeling that there was a need for a classification system to incorporate all of these amazing and expanding diversity of life on Earth. So maybe we needed this. Maybe we needed to have this great database. So he wrote Systema Naturae, in which he describes this classification system and kept on revising it throughout his life. 13, I think, editions published in the 17th to 18th century. My issue with it emerges with the way that we latch onto this classification system. So the grip is so tight because our brains like classification. We like to categorize things and we like to put things in nice, discrete boxes. We do it with everything in our lives. You've probably got a bookshelf to your right. I look at my books and think, well, there are books there which are fiction. There are books which are non-fiction. There are books which are plays. There are travel guides. There are thrillers and there are literary novels. What do any of those categories actually mean? Why do they exist? Well, they help us to choose books to not waste our time having to read every single book before deciding whether we like them or not. Richard Dawkins has a phrase, which I really like, which is the tyranny of the discontinuous mind. We like to categorize things, and it has a tyrannical effect on how we view the world. Now, the problem with where this started for me as a difficult, problematic idea is that biology isn't like that. It's messy. And Darwin showed that it's transitional. All species change over time via this mechanism that he described in 1859 and that we've subsequently shown and elaborated on to be complex and beautiful and capable of creating the wondrous forms. I know that a blue whale is different from a beaver. There is a functional difference. There is an obvious difference. And as we discovered bacteria and the dominant forms of life on Earth, so the microbial world, we need to be able to say that these things are functionally different. But it's at the edges that classification and taxonomy and biology become the thing that I said at the beginning, not useful. Because what they do is reflect the initial setup, which was a creationist view. This is what a thing is. And I think in biology and probably in science more broadly, and possibly in life more broadly, we shouldn't be interested in what a thing is. We should be interested in what a thing does.
One more comment about Linnaeus. When I was reading about him, it's an odd name, Linnaeus, Carl Linnaeus, for a Swede. And it turned out that he came from a culture where your name was your father's name with son added. So your kids would be Adamson. But his father thought, no, we need something more definitive than that. We need a family name, which will not vary from father to son and father to son. And it will create this thing which we can call the Linnaeus family, which is quite interesting. I mean, I don't want to overdo the biography
It's
here,
exactly what he does, isn't it?
It's weirdly interesting, isn't it? And actually, when you think about the taxonomies of the world, family is one of the really interesting ones, because there are a million ways you can define the limits of a family, from the nuclear unit through to, like with a family tree. If you run a family tree backwards, it expands outwards. If you start with a distant ancestor and run it forwards, it expands outwards in exactly the opposite way. So where do you draw the lines? And so to come from a family where the father decided, we need to name this damn thing so that everyone belongs to the same category.
I hadn't thought about that. And I visit Uppsala quite a lot. My brother lives there. And I've been to Linnaeus's grave many times. So he's buried in the cathedral in Uppsala, which is a lovely town, an amazing university town. And there's on the stone where his name is engraved, there are also belemnites. So, which are just embedded. And, when you walk around old buildings or buildings that use old stone, you often see the remnants of fossils. And I always think that's a wonderful thing. I think there's a deep irony in the fact that he's buried literally underneath a stone which has organisms which died probably 450 or 600 million years ago, at a time when he was unaware of, wasn't interested in, didn't describe evolution, and had no idea that the Earth was as old as it was.
So I want to talk about two things now. So one of which is why this might be a bad idea in biology. And then I think we're talking almost by analogy in some ways when we talk about, say, for instance, it's a pretty bizarre taxonomy, actually, fiction and nonfiction. People often point this out for books. Like, when did fiction become the defining thing? And then everything else is not that thing. But it's very interesting how it shapes how people talk about writing and books. But if we do the biology first, so where are the dangers here for you? So as a lay person in this context, it doesn't seem particularly dangerous. Like you say, like you, I can tell the difference between a beaver and a blue whale. So I don't need a taxonomy to tell me that difference. But where does it become dangerous, like you said?
There's two answers. I'll be as brief as I can, because the first is that when I started to think like this was in maybe, 15 years ago, because, having grown up all my adult life, I've been a biologist. And so classification system that's what we do, it's how we work. I was working on projects to do with the origin of life, not as a researcher, more as a science communicator and writer. I wrote a book about the origin of life. And the question, what is life, has dominated research in the origin of life for a century now. And I think it's the wrong question. I think it's the wrong question to ask. There's lots of controversy about what the correct answer is or what the most useful answer is. And NASA has a particular definition because it's interested in looking for traces or potential existence of life on other planets. Schrödinger wrote his great pamphlet and lecture, which informed the sort of study of origin of life. And it was called What is Life? And every biologist who wanted to make his name and it is almost exclusively his as well, so I just corrected myself there, make his name in this area, it has a chapter in a book called What is Life? And I think it's the wrong question, because it presupposes that it is a definable thing with discrete edges. And I think it's antithetical to science, because you're trying to describe what a thing is rather than what it does. I think it's antithetical to science. And the reason I first started thinking about this was because in writing the history of origin of life science, I realized that many of the experiments that were trying to describe what life is were not actually answering scientific questions at all, because they weren't addressing the underlying biology of what a thing does. So you end up in situations where you're saying, is life the result of a prebiotic bunch of chemicals gets electrocuted by lightning and suddenly somehow fuses into something which marks the transition from chemistry to biochemistry? Now, did that happen? Well, we don't really know. But what we do know is that you and I and bacteria and beavers and blue whales do not run on electricity in that way. We do kind of run on electricity, but generally, if you get struck by a bolt of lightning, it has the opposite effect of creating life. So it struck me that the scientific questions being asked were not the right ones, because so many people were trying to define what life is and then come up with a model which described that. So if your obsession is what is a thing and how did it come to be like that, then I think you might be working in an antithetical way to the scientific process itself. So that's one example. The second example was in 2009, a question which had been outstanding for 100 years in science was definitively answered. And it was, are Neanderthals our cousins or the same species as us? Since they were discovered in the 19th century, they were categorized as Homo neanderthalensis, so a different species under the Linnaean classification system. And during the course of the 20th century, there were lots of scientific disputes about how they were related to us. And it was answered with genetics in 2009 because it showed that you and I carry Neanderthal DNA and Neanderthals carried Homo sapiens DNA. So then the question, are they the same species as us or are they a different species as us? This is now a sort of undergraduate question in evolutionary genetics. And the answer, to, as far as I'm concerned, the short answer is the question's wrong. Because if the definition of a species is two groups of organisms that are incapable of producing fertile offspring together, then we are living proof that they must be the same species as us because we are part of the fertile offspring of a pairing of a Homo neanderthalensis and a Homo sapiens 50,000 years ago or so. So they're either the same species as us or the species definition is wrong. And my take on this is neither of those questions are interesting to me. What I want to know is what happened. What happened in an interpersonal level in Western Europe for 40,000 years ago, and what happens at a biochemistry level. What are the genes doing when that Neanderthal sperm hit that Homo sapiens egg? So those were the two sort of scientific moments where I sort of cocked my head and just went, why are we doing this? What is the utility scientifically in saying Neanderthals are a different species from us?
So in that second case, I can see how one of the consequences of changing how we view it would be a certain kind of humility on our part. I think, we're less clearly defined as a species. I think traditionally Homo sapiens have felt superior to Neanderthals, and now it's more complicated, and people joke about the fact we all have a bit of Neanderthal in us and so on. And the human applications of this are wide, and we'll talk about that in a bit. But when we as humans are looking at the natural world, and we extend your argument to say, look, there are going to be a lot of these cases where we've drawn artificially tight boundaries. The boundaries are too distinct. And as you zoom in, or maybe as you learn more, it gets fuzzier. Why does it matter, though? I mean, where do these cases become problematic for our understanding of the natural world? So you're not interested in the question. You think it's the wrong question. So it matters, like undergraduate exams should have different questions in them. But where are the cases where it leads us to fundamentally misunderstand what it is we're dealing with because we have been too schematic because of Linnaeus or his inheritance?
So there's the scientific answer and there's the broader cultural context answer. The scientific answer is that in closely related species, more and more we discover that, for primates or for birds, things that have previously been classified as separate species, therefore incapable of producing fertile offspring with each other, is just not the case, right? So we learn this and then later on we go, it turns out they could reproduce, and that means that what we taught you is incorrect. Speciation biology is a really important part of evolutionary sort of ethology. What happens when a population which was initially together becomes either reproductively or physically isolated to such a degree that they stop being able to reproduce with each other? These are important questions about the radiation of life on Earth that were first set up by Darwin and others. So I'm not disputing that those events are important. The cultural one is that I think that it just reinforces our desire to put things in discrete classes. The word itself, species, it means specific. It implies this discreteness that we can say this is a unique thing and doesn't blend or merge at the edges. I think that is culturally important generally, and I've ended up being provocatively, I don't necessarily really, I'm not going to argue, this isn't going to be the hill that I die on, but I often think, we talked about books a bit, but political taxonomies and classifications for cultural things, I find annoying. I had a girlfriend once who said, I don't like black and white films. I know this is a trivial example, and it's utterly meaningless. Well, what is it? Is it just the lack of color that you don't like, or what is the categorization that you're actually applying here? And as I explained this over an hour, she slowly walked out and I never saw her again. But I think politically it can be genuinely pernicious. The sort of name labeling that occurs a lot in politics, I don't know whether this is the same as it's ever been, but it seems particularly significant today that terms become toxic or they become weaponized. And I don't really know necessarily what they mean, but people who are leftists or fascists or the whole discussion about the utility of the words racist today. A lot of my work is about scientific racism and race in general. Are these terms useful if someone says you're a socialist? And today, in many quarters, that's a real insult, and it's a real way of tribalism and categorizing your political opponent. That has evolved over time. That's one set of cultural issues I have with taxonomy as applied more broadly. There is a Linnaean version of this, which I think is really important too, which is that it is Linnaeus who comes up with the first categorization of humans in the 10th edition of Systemae Naturae with subspecies designations. There are 4 for humans, and they are Homo sapiens, Americanus, Europaeus, Asiaticus, and Africanus. And they become the 4 races of humans. And it is effectively the birth of the era of scientific racism. Now, when you read the initial description in Systemae Naturae, where this first occurs, the categorization is written as the first characteristic is skin color. Homo sapiens americanus are red-skinned. Homo sapiens europaeus are white-skinned. Asiaticus yellow-skinned. And Africanus black-skinned. Now, the second physical phenotype, the physical characteristic that is used for these 4 categorizations is hair, color, and texture. Thick black hair for Asiaticus and Americanus, pale hair for Europeans, and curly, tight black hair for Africanus. And then the next descriptions in the same sentences are unequivocal value judgments, which are in any era racist. So Americanus are stubborn and governed by customs. Africanus are lazy and sexually capricious. And big surprise, Homo sapiens europaeus are gentle, acute, and governed by laws. And so you have effectively in Linnaeus's great foundational work of biology, where classification is the central idea, you also have the birth of not only a classification for humans, but the birth of scientific racism, because every taxonomic description of humans from that point onwards until the 20th century is not just classification, it is hierarchical, and there isn't a single version in which white Europeans are not superior to the other races of man. Now, in the 20th century, genetics demonstrated that this biological concept of race was fallacious, and the racial classifications that we use do not correspond with the true metric of human diversity, which is at a genetic level. So you've also got the broader political issues of saying, it's a black and white film, or you're a socialist or a conservative. You've got the scientific problems of saying, well, is this crocodile a different species from this crocodile because they appear to have just had sex and made a baby? And then you've got the birth of one of the most pernicious ideas that anyone ever had, which is scientific racism. And look, culturally, we are still wedded to those classifications systems. Socially, we still talk about black people. It's a meaningless description from a biological point of view, but that is how we talk. And I argue that it's born of a Linnaean, effectively creationist, tyrannical, discrete obsession that humans have with putting things in neat boxes.
It does now sound like a very bad idea. It also actually, what you just described does remind me a bit of our conversation about eugenics, because that move from species to subspecies. So if you stop at species, there's a version of this which says, even before we know we've all got a bit of Neanderthal in us, we're all Homo sapiens. There's a kind of unifying aspect to it. But you go to the subspecies level and it becomes pernicious, hierarchical, divisive. And it's like something that works to a scale, a scientific scale, where it makes a certain kind of sense for us. But the human impulse is then to bring it down to our level to do the work that we want it to do. The same way the eugenicists took a time scale and they shrunk it to a point where the science is bastardized because they're turning it into something which is useful from generation to generation. Here's Linnaeus taking something that if you stop at the species level, okay, there are problems, as you described, with drawing the boundaries. But that social consequence, the birth of scientific racism, is not there. It comes from the human impulse to take something that makes sense on a certain scale and get it down to the scale we want it to operate at, which in his case was to create a hierarchy of human races. And then it becomes a nonsense. And it is a bit like what the eugenicists did, actually, in a way. So something that if you, as you said in that episode, it works over a few thousand years, but you want it to work over 30, and then it becomes ridiculous. At the species level, there are problems, but it makes a certain kind of sense. But subspecies, that's just evil wishful thinking.
Yeah, it is. And there's an interesting scientific angle to this as well, purely from a sort of academic point of view, which is that during the 20th century, our model of human evolution was that there were two big camps. There were the multi-regionalists and the out of Africa people. And the multi-regionalists suggested that the different physical characteristics of humans that we see today emerged in situ around the world. And so therefore, Homo sapiens was a widespread, global, possibly separate species. And the out of Africa theorists said that we're an African species and that most human evolution occurred within the continent that we now call Africa, and then populated the rest of the world and developed the different phenotypes, the different physical characteristics over the last 100,000 years or so. Now, genetics and other branches of science have shown pretty categorically that the out of Africa hypothesis is true, although there are many new interesting nuances to it. It looks like there were more out of Africa's events taking thousands of years than we had previously considered. There's the emergence in Chinese science of a resurgence of the multi-regional hypothesis today. This is happening right now, where some scientists, and we think of them as cranks, but we often don't know what's going on in Chinese scientific circles, but have brought back multi-regionalism and suggest that people of Chinese descent or ancestry are such a clear different branch that they might be a different species or have a different ancestry, evolutionary ancestry, than, for example, people from recent sub-Saharan African descent. Now, what's interesting about that is that after Linnaeus, it's a perfect recapitulation of an argument that was happening in the 17th and 18th century between the big heavyweight thinkers of the time, which were broadly categorized as the polygenists and the monogenists. And remember, this is pre-Darwinian, so everyone is still basically a biblical creationist at this point. And the monogenists said everyone is derived from Adam and Eve in the Garden of Eden, and the different characteristics you see have emerged over the world as they migrated from Eden. Whereas the polygenists said they migrated away from Eden into their locations and then developed into the characteristics that we see today. Kant is a big monogenist. Voltaire is a big polygenist. Voltaire thought that sub-Saharan African people might be a different species to white Westerners, that great Enlightenment thinker that we revere so much. But again, it is neither of those things are true. There was another scientist, well known in Germany, but not so well known here, Gottfried von Herder, who argued that actually this is a nonsense. And if you spend any time in Africa or traveling the world, you don't see these discrete boundaries at all between people. You see continuity. And he suggested that the continuity that you see around the world in people's physical characteristic is a reflection of their migratory patterns over evolutionary time. He didn't use the word evolutionary time because it's pre-evolution. He was basically right. In reading him a few years ago, I made the mistake of thinking, yeah, you got it spot on. You've basically unpicked the birth of scientific racism. He was also terribly anti-Semitic and said some bloody awful things as well. But anyway, again, I'm talking about some big societal issues, but I think they have at the root of them this intrinsic, like the Dawkins phrase, tyrannical desire to categorize, which is inextricably wedded to the politics of what was wanting to be achieved by powers, mostly in Europe at that time.
One of the challenges, though, as you've just described it, is, so on the one hand, Linnaean taxonomy is the underpinning of scientific racism. And on the other hand, you want to say that the term racist is an example of a bad taxonomy. So clearly, sort of two different things are going on here. And this might sound sort of a bit meta, but part of the problem with this argument is that we want to bracket taxonomy as a bad idea, but it clearly kind of leaks in a way. So taxonomy creates something bad, which is scientific racism. But we also want to say the category of racism itself is an example of the ways in which we want to put things into these discrete boxes. And we need some taxonomies, but not others. We can't get by without these shortcuts. So it is quite hard actually to draw the boundary between good and bad taxonomy. I mean, as I hear you speak, I find myself thinking, you've completely sold me on why it's a bad idea. And at the same time, we kind of need it to have the argument that you and I are having.
I agree. We need to be able to describe things. But I think that it is the tendency to make discrete categories rather than to reflect complexity, which is where the problem lies. I think that there's a sort of scale issue that is problematic within different branches of science. And so, for example, if you're a zoologist who deals with organisms, you tend to look at populations and individuals. And if you're a demographer, you look at large, countries or large populations, or an epidemiologist. And if you're a molecular biologist, you tend to look at molecules. Now, as a geneticist, an evolutionary geneticist, I am, this is again a provocation, and plenty of population geneticists would disagree with me, but the unit that we are most focused on is the gene. And the whole idea of the gene-centric view of evolution, the selfish gene as popularized by Dawkins, is that is the replicator, that is the reproductive agent. And our bodies are just husks to carry genes into the future. It turns out the best way for a gene to perpetuate into the future is in concert with 20,000 other genes in one of these, I'm gesturing at our physical bodies. But there is a sense in which when you do particularly what I do in looking at population genetics, incidentally, a scientific movement born out of the ideology of eugenics by some key eugenicists such as Carl Pearson and Ronald Fisher in the 1920s and 30s. What I am most interested in is the passage in the evolutionary ancestry of individual genes and how they've changed over time. So it's not like I'm looking at you right now. It's not like what I see is a collection of genes there and I can trace the ancestry of every single one. I see you as a human being. But from a scientific point of view, I'm really only interested in individual genes that you carry, because that's the scale that evolutionary biology operates at.
And so the boundaries of my body are just a sort of arbitrary and meaningless category. My body's just a dispensable category for that.
In a sense, and I think this relates to another branch of my work, which is about genealogy and why, we obsess about genealogy and our own ancestry within families. You've already said that, the concept of a family is not very discrete or precise. But there's a weird mathematical phenomenon emerges out of looking at genealogy as it really is, rather than as we like it to be, which is in, family trees and clean lineages, where actually we only have to go back, a few centuries to discover that we're all descended from the same population. And you only have to go back 1,000 years in Europe to come to the point where the population of Europe at that time, 1,000 years ago, is the ancestor of every single European alive today, right? I won't go into the maths of it. It's wonderful, utterly baffling, totally perplexing. But if you are alive in the 11th century in Europe and you have any living descendants today, then you are the ancestor of everyone living today. Now, this is just maths that falls out of how family trees actually work. So there's another version, which is basically what I was saying a minute ago about what I'm interested in the gene, is from an evolutionary biology point of view, we have to stop looking at family trees and have to look at the passage of individual genes. And there's a slow emerging movement, which is we're trying to do. I know this is a very scientific point, but I think it speaks to the broader issue of, papers are published every week which say, you got this gene from Neanderthals. During COVID, that happened very specifically. A susceptibility to infection by COVID was inherited from Neanderthals some 40,000 years ago. So what? As were half the genes in that first pairing, what we lovingly refer to as a gene flow event. But it sort of plays into that narrative. When you see it reported, it's you inherited that gene from a different species. I've become a sort of scientific racism hammer. I see the nails of scientific racism everywhere, and possibly I see them too often. But it is a similar sort of sensibility, when actually what I'm really interested in the trajectory of that one thing.
Two more things I want to ask you about taxonomy, different from what we've just talked about here. So this question, I'm at the limits of my understanding. In fact, I'm beyond the limits of my understanding, but still, as I understand it, the world of search engines and large language models and really cutting edge tech, including what we're calling the AI revolution, though it's not particularly I yet, all of that is entirely taxonomically based in the sense that these machines can only order information and data and then reproduce it for us in a way that looks like it's useful and gives us what we want. And indeed, with large language models and AIs, in a way that mimics human speech by having an underpinning which is hierarchical and taxonomical. That's the only way you can do those shortcuts. These machines are quick. They're not infinitely quick, and they have to have their own shortcuts. And I don't know, but I have a sense that we are entering a much more taxonomical world as a result. I mean, a world in which our communication is mediated by these machines and our acquisition of knowledge comes through search engines and other things. We know some of the obvious flaws with that, which is certain kinds of searches are geared in particular directions because of the way the information is organized. So, if you look up, and some of it has its roots in scientific racism, that is, or it has its roots, I should say, just in racism. If you Google what is beautiful, you will get images of white people because that tracks the searches, but also the way the information is organized. So I don't know, but I have a sneaking suspicion that the things that you don't like about taxonomy are going to get worse.
Yeah, you may well be right. I mean, as you were talking there, I was just thinking about the flexibility and the mutability of language. I've ended up being, predictably, very much a descriptivist in terms of thinking about grammar. This used to come up. So I present various programs on Radio 4, and one of the weekly programs I used to present was called Inside Science. And the single most common complaint that we would get was from grammar pedants. So every week, people would write in and say the plural of bacterium is bacteria, or would criticize me for saying decimate. I mean, I actually because I'm very childish, I would deliberately use the one that I assumed that they thought was wrong, or worse, I'd use both in the same sentence but meaning the same thing.
You should have tried talking about referendums and referenda on Radio 4 during the Brexit referendum. You can imagine.
I don't have the patience, the stamina for that. Decimate is another one. And one of the interesting things about grammar pedants is they often are not pedantic enough, because it turns out that decimate has been used not just to mean the tithing, but also as a general wipeout since its inception. And it took me 10 minutes of Googling to find that out. But no, Mr. Simpson of Kent would write in and say, you must stop using it that way.
And it should be said 10 minutes of Googling, because Google had a taxonomy that allowed you to find that information very quickly. So we need to be careful that we're not.
No, that's a fair point. I don't know enough about how the taxonomies and classifications in AI will or do work, but language changes, and it changes through usage. And I think humans are very capable as learning machines to detect the subtleties in how language changes over time. And I wonder if AI I'm sure it will be in the future, but whether that is being coded into the language models that it's learning. So, I think a lot about how I love thinking about swear words, and I love thinking about the differences between swear words in different countries, or, the tonal variance in me describing you as, we've never met, but if we went to the pub, I might say to you, mate, do you want a drink? Or if we really disagreed about how significant taxonomy should be, I might say to you, mate, or do you want to take this outside?
Exactly in that tone. Yeah, two very different uses of the word mate there. Subtly different. I could hear it. I could hear the threat in the second.
I refer to my son as pal. So, he's my pal. But you go to Glasgow and someone says, do you want to have a talk about this, pal? That's a very, very different context. So I'm being slightly trivial and slightly silly about it. But I suppose, the potential errors that AI might make in failing to comprehend the language which it actually uses, which is binary, and the infinite mutability and nuance that happens with human communication that you only get by learning, by speaking it, by interacting with others. I wonder if, maybe it's going to be the sorts of problems that you're talking about, that the taxonomy in LLMs will not initially be sophisticated enough to recognize the difference between all right, pal, and all right, pal.
And it's also a version of what we talked about in this episode, and also the one on eugenics, which is these large language models are drawing on enormous data sets, but they are this is an ugly word, but they're very presentist. I mean, they are drawn from the very, very recent history of language, because that's what's out there. There are more photographs taken in the last 6 months than in all of human history before that. So there is something very squeezed about the time frame of this, even though the scale is vast. And that, at least potentially, as the underpinning of a taxonomy, could be bad news, I think. I don't know, but I think it could be bad news.
Well, I think this comes up a lot in my work as well, because the flexibility and the mutability of words that we continue to use today is very recent. I talk about race a lot, but when I talk about race in relation to eugenics, it is often in reference to the Irish, or so many of the eugenicists in the UK were keen eugenicists because they were opposed to Irish people or Italians. Now, at the time, when you read the literature of the day, the Edwardian literature, it refers to the race of these people. And it sort of means type or country, and it's very flexible. And so when people say eugenics was inherently racist, you go, I have to say, yes, it was, but not the way you're thinking, or potentially not the way you're thinking about it because of how we talk about race today. I was once presented with the argument that The Origin of Species was a racist book. I mean, it was a terrible, fallacious argument. But it was because the subtitle, I happen to have a copy right on my desk here, because I always have a copy on my desk here, but the subtitle is Preservation of Favoured Races in the Struggle for Life. Now, anyone who's read any Darwin and knows anything about the history of Darwin and evolutionary thought knows that there's no mention of humans in The Origin of Species.
He's not talking about the English, the Italians, and the Irish there, is he?
No, let alone. Exactly. It's, when he's talking about races, he's mostly talking about cabbages. So, was he a racist about cabbages? Yes, definitely. Because so 100 years ago, a word that we use today and has a very specific meaning has a very different contextual meaning then. And, will the AI be capable of recognizing that mutability? I guess so one day, but how does it code that?
The last one, so I'm interested in it, and on this podcast in other contexts and in the future, we're going to be talking quite a lot about counterfactuals. And I'm very interested in what ifs. So it seems like there is quite an interesting what if with Linnaeus, which isn't the case, say, with Darwin. So if Darwin hadn't done it, someone else would, I think, because it's true on the whole. I mean, nothing's true, but it's true enough. It's one of those scientific revolutions. But it sounds a bit like with Linnaeus, it's not obvious that that's the case. Actually, some things get fixed at a moment in time. They are useful and they chime with something that we kind of feel like we wanted or needed. And they also fit with a theology or an ideology which is prevalent, and then they outlast their useful staying power. It seems like it's more like one of those scientific revolutions where there is a meaningful what if. So it's not like if Linnaeus hadn't done it, well, the person 2 towns along would have come up with a similar kind of taxonomy. Do you think there is actually a possible fork in the road here? So the young Carl, unfortunately, doesn't survive his childhood illnesses. And actually, you do get a different way of classifying and thinking about the natural world? Or is it so basically useful, even if bad, wrong, annoying, and dangerous, that we would have wound up with a taxonomy like this anyway?
That's an amazingly fascinating question, and I'm not going to answer it. I'm going to just do, because I love counterfactuals as well, and I think they can be really useful as well. I set my students an essay, which is the counterfactual of the invention of scientific racism. So it basically goes like this. With the invention of discrete classification of human subspecies that starts with Linnaeus, we have a long-standing but scientifically inaccurate version of human variation, which eventually is dismantled by the advent of modern genomics. The counterfactual is, and this is what I asked them to discuss, is imagine a world where genetics was discovered before Linnaeus. I know that obviously that is completely impossible because molecular biology doesn't exist until the 20th century. But imagine that in 1730, some equivalent of Crick and Watson plus the evolutionary theorists plus Darwin go, we've just discovered that genes exist and they vary between people, and this is how it works. What does scientific racism look like today? That's the question. And I think the reason I think it's fun to explore is because it plays to a point that I often find myself making, which is that whilst looking at racism from a scientific and historical perspective, I think is useful in dismantling it as a scientifically valid idea, but also to understand the fact that it's an expression of hegemonic power. Bigotry is permanent, right? Bigotry exists in all cultures and will presumably continue to exist until we reach a sort of Star Trek level of human happiness. No, there was lots of bigotry in Star Trek as well.
And classification will always exist as well. There was a hell of a lot of classification in Star Trek.
Yes, there was. It's a very bad analogy, and I'd like to withdraw it. But do we have the same types of racial bigotry that we endure today that are effectively born in the 17th century? So I think a lot of people don't realize, because we use skin color as a primary determinant of racial classification since Linnaeus, don't really realize how ephemeral it is as a classification system, because it doesn't really exist before that. People recognize pigmentation differences and recognize physical variation pre-16th century Europe. I'm not saying everything was, happy and sunshine in those days, but they just tended not to be the defining characteristics for the othering of other people. I cite the Homer's use of pigmentation in both the Iliad and the Odyssey as an example of recognizing differences in traits, but using, there's not a one-to-one translation of what the words actually mean, but recognizing that they change over time and they're fluid, but also they're associated with traits rather than the sort of immutable biological characteristic, which is what defined scientific racism. Odysseus himself is sometimes swarthy, sometimes curly-haired. He was a complex guy. But it's really only in the 17th century, and yes, with Linnaeus, that pigmentation becomes the characteristic that we still use today to define people, and it's scientifically meaningless, and it is the cause of some of the most pernicious crimes in the history of our species. So I'm sticking with it. Taxonomy was a bad idea.
Do follow us, as always, on Twitter @PPFideas. If you sign up to PPF Plus, you will get ad-free listening, and you will get the bonus episodes that accompany this series and all our series. Just go to ppfideas.com or click on the link that you'll find in this show description. That's where you can also sign up for our fortnightly newsletter. Next time on The History of Bad Ideas, I'm talking to the author and journalist Helen Lewis about the history of women against women's suffrage. Why did some women want to deny women the right to vote? This has been Past, Present, Future, brought to you in partnership with the London Review of Books.